Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Pivotal for sponsoring today's event. Pivotal has been doing a series of educational webinars in partnership with Data Science Central, and they're simply a wonderful partner and supporter of the Data Science Central community, and we're very honored to have them sponsoring today's event. I would also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Splunk, Tableau, Teradata, Hortonworks, and TIBCO, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you have not had the opportunity to view them, I would encourage you to take a look, as they do provide some very useful information. Today's webinar is entitled Big Data Integration. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be approximately 1 hour long. We have a single moderator and 2 panelists that I'll introduce to all of you in just a few moments. We should have about 15 minutes for Q&A following the presentations, and this webinar is being taped and will be made available later on this afternoon at Data Science Central. I would also like to encourage our attendees to provide questions throughout the presentations. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison, and I'm one of the co-founders of Data Science Central, and I will be your host for today's event. I'm very pleased to introduce today's moderator, Dave Menninger of Pivotal. David is the head of business development and strategy for Pivotal. He has also worked as VP and Research Director for Ventana Research, with stints at Vertica Systems, Oracle, Applix, InfoSense, and IRI Software. Today's panelists are Itamar Ankorian of Attunity and David Bessemer of Composite Software. Itamar is the Vice President of Business Development and Corporate Strategy at Attunity. In this role, he is responsible for Attunity's market and product strategy. He has more than 15 years' experience in marketing, business development, and product management in the enterprise software space. He holds a bachelor's in computer science and business administration and an MBA from Tel Aviv University. David is the CTO of Composite Software and is responsible for driving the technical vision of the company. David's technical background includes CTO of eStyle, product marketing at Next Computer. He also built a program trading system on Wall Street and researched natural language processing systems at GE's Corporate R&D Center. David holds a bachelor's in computer science from Michigan State University and a master's in computer science. Welcome to you all, and thanks for being with us today. Big data integration is a key operational challenge for today's enterprise IT departments. IT groups may find their skill sets, workload, and budgets overstretched by the need to manage terabytes and petabytes of structured and unstructured data in a way that delivers genuine value to the business users. In today's webinar, we will examine these challenges and the ways in which organizations are overcoming big data integration challenges. So David, with that, I'm going to turn it over to you, and you can begin when you're ready.
Okay, thank you, Tim. First of all, I appreciate the opportunity to speak with the Data Science Central community. What we'd like to do today, our role as Pivotal, is really as sponsors here. I'll give a very brief introduction to Pivotal, but today's webinar, like the previous webinars we've hosted here, are really about our partner ecosystem. And we want to use this opportunity to introduce you to some of our partners, but I'll set a little bit of context as to who Pivotal is and why we're interested in introducing these partners to you. So Pivotal was formed in April. We're led by Paul Moritz, former CEO of VMware, and we combined some assets from EMC and VMware into a new organization called Pivotal, focused on redefining the enterprise platform as a service capabilities. And if you're not familiar with that concept, I like to give the one-story elevator pitch as enabling a new class of applications that leverage big, fast data. And I like to say in cloud-like infrastructures, we also emphasize cloud independence because we're not tied to one particular cloud infrastructure. But the point here is combining three elements: applications that deal with big, fast data, and cloud infrastructures. And what we see happening in the market is that the separation between applications and data is vanishing. So applications and data are becoming completely intertwined, and we all run our businesses with applications. Those applications generate data. We are now, we're generating larger and larger amounts of information and new types of information, and we need to be able to analyze that information and derive new insight, which then, in fact, presumably lead to new business processes or changes in our business processes. And so that's the cycle that we're attempting to address here. We talk about it as big data, but really the core here, the core element here is about speed. We need to be able to do these things in a time frame that allows us to react to changes in the market and react to specific interactions with customers as we're meeting with them. So I've listed here our portfolio of products, and I'm not going to go through these. We can give you more information about those in a separate discussion. But I did list out here the portfolio of our products and how they relate to these different portions of that cycle we just talked about. And we refer to this collective platform as Pivotal One. And you may have seen our announcement last week introducing the first version of Pivotal One to the market. Today's discussion is really focusing on the data portion of this platform and talking about how our partner community can help you bring information together to this platform to be able to analyze that information and use it in your applications. If you want to learn more about the platform, you can get information from our website, gopivotal.com, or you can follow us on Twitter. But with that brief introduction, I want to introduce you to a couple of our ecosystem partners who help bring the data together for this process. And we'll begin by turning it over to Itamar from Attunity. Itamar?
Thank you very much, David. And thank you very much, team. We appreciate the opportunity of joining the team here and talking to the Data Science Central community. We've been working for many years helping organizations to make data available so they can speed up analytics. And as I start here, I want to follow on your note, David, about the speed, the need for speed, the need for organizations to accelerate the way in which they can do analytics, in which they can acquire data and make it available so they can quickly drive analytics, improve their applications, and speed up that cycle that you presented before. So Attunity is all about accelerating big data analytics, accelerating the big data loading, making it available for analytics. And we're going to talk today about how we can help organizations move the data that moves their business. So as a very quick introduction about Attunity, Attunity is a leading provider of software solutions that enable high performance, fast, easy, big data movement on premises and in the cloud to enable data to be available where and when people need it. A key focus in that is on BI and analytics. We're a Nasdaq-traded company with a global presence, founded over 20 years ago, with over 2,000 customers across all major industries that use our software on a global basis. And our main focus in terms of analytics is on delivering data for BI analytics. This is typically some of the key challenge we see customers facing today as they try to accelerate and drive more value from big data analytics. And with Attunity, we focus on enabling the delivery, the availability of data, anytime, anywhere, to bring data from operational application systems, from other data warehouses and other analytic platforms, from either structured or unstructured, like files and web logs, and bring all the data into different places where customers want to analyze the data. We also recognize that customers and enterprises may need to use different types of data warehouses or analytic platforms depending on their analytic workload. So we enable loading data into a data warehouse or either into a BI or analytics server, into Hadoop or into a cloud environment. Again, all depending on where you need the data to be to facilitate your big data analytic process. In that respect, we see customers using different use cases. And I want to highlight here the use cases we see customers leveraging where Unity can help customers to accelerate the data availability for analytics. So the first most common use case that we see is ELT, or extract, load, and transform. We find that we see more and more customers that today leveraging an ELT versus a more traditional ETL process to expedite the data process, to leverage the capacity and performance of the data warehouse and analytic platforms that are available today, like, of course, Pivotal Greenton database or Pivotal HD, and able to quickly automate the process of loading data and making it available. We also see customers that look at CDC, which can be done in an ELT form, but CDC focusing on change data capture is more about the real-time, incremental, efficient load of data as it changes, bringing deltas of information continuously into the data warehouse or analytic environment. We also see customers that leverage modern, new types of analytic platforms for the big data analytics by offloading workloads from other enterprise data warehouses. So large organizations that may already have one type of enterprise data warehouse may benefit from accelerating the value they get from big data analytics by adopting modern data analytic platforms like Pivotal Greenplum and offloading data from another enterprise data warehouse into that environment. Naturally, other use cases include migration, as customers see one type of data warehouse or analytic platform that better suits their analytic needs. And we also see customers that are adopting data warehouses in the cloud where they need to address challenges like loading data efficiently over wide area networks or the internet. So different types of use cases. And in the cloud, customers want to benefit from the agility, from the ability to scale up and down dynamically with elastic environment, but need a way to get the data there so they can run their analytics. And finally, of course, combining Hadoop into all of that is yet another type of use case. For example, how do you bring data into Pivotal HD in a way that is accelerated, easier, so you can derive your value faster. So these are some of the common use cases that we see customers dealing with almost every day, and what we're geared to helping them achieve. So we want to share with the community here some of the typical challenges that we see customers run into and where we focus our efforts on helping them address them. We largely call these the data loading bottleneck, which is what gets in the way of accelerating and getting the data into your data warehouse or analytic platform so you can analyze it. And we see two types of common or traditional pains and challenges that customers go through. On one hand, it's more process related. Making the data available actually takes too long time, or it costs too much. In the life cycle of an analytic project, the process of actually making the data available may take more time than anything. So if you can accelerate that, you take away a lot of the challenge, and you can more quickly get value from it. So the other challenge on the process side is the lack or dependency on developers. So the fact that the process of loading data and making it available for analytics is developer-centric creates a challenge and the dependency on those scarce resources. And then on the other side, we see a lot of performance issues. We talked earlier about very large volumes of data. How do you handle movement of such large amount of data within the window of time that you have? How do you enable a timeliness of data to make data real-time enough for your business process needs? How do you avoid overhead on your operational systems? How do you handle moving volumes of data, especially over wide area networks, if your data center and where your operational systems are, your source data is, and the data center where your data warehouse is, are different ones? How do you then move the data? Certainly if you're moving to the cloud. So these are typical challenges that we see customers facing as they're trying to accelerate the process of getting value from analytics, and where we focus on helping them address. So with Unity, we focus on accelerating big data analytics in a way that is designed to enable self-service. So in order to expedite, to speed up that process that David showed earlier, we want to enable the end users, the people who need to use the data, to self-serve themselves, to reduce the need for IT resources and budgets to get involved in that process. The more we can take those out, the more we can speed up that cycle. So Attunity is all about enabling a solution that loads the data in an easy way, without coding, with less complexity, provided pre-automated, optimized processes, enabling fast, high-performance integration, enabling real-time CDC and integration into your analytic environment with optimizations over for large volumes of data, both in the local area network as well as wide area network. So the whole idea is to get more data in less time and less cost. As an example, one of our customers, Equifax, which in fact most people have heard, of course, about Equifax, one of the world's largest sources of consumer and commercial data. And with Equifax, they're using Attunity as a global solution for loading data. Their needs was to enable low latency data loading into their data warehouse and analytic platforms. And they need to load data from several different sources, and they need to replace what previously was a manual, time-consuming, nightly batch process. They used Attunity and loading Pivotal Greenplum, and the benefits they reaped from accelerating that process was to improve the services, the solutions to their valued customers. At the end of the day, data is their business, and to quickly extract insight from big data analytics, and at the same time significantly reduce the cost and time in the data loading process. So that's an example of the value proposition that we've talked about in accelerating the data loading process. At a high level, Attunity provides a server which enables to instantly replicate data from a lot of source databases, Oracle, Exadata, SQL Server, DB2, on a variety of platforms, Sybase, and others, into Pivotal Greenplum database or Greenplum HD, as well as other systems, a lot with integrated, optimized integration. And you can write, it's all designed to reduce the impact on your environment and accelerate the time in which you can get the data and make it available. The Attunity server can run as one instance or multiple instances. In the server, you can run one or more tasks for loading the data. Those tasks you can automatically map between the source and the target, so you don't need to do any coding. You can apply some Iterate transformations, and you have very flexible filtering options. Once you define those will automatically be applied both for the bulk loading, the initial snapshot of your data, as well as an incremental load of the data using CDC technology, again, change data capture, that captures data out of the source system's logs in a way that reduces impact and facilitates efficient real-time data delivery. On the integration side, we integrate specifically to Pivotal in order to provide high level of performance in terms of loading large amounts of data, both in batch as well as in real time, again, whether it goes to the Greenplum database or Pivotal HD. So quickly talking about some of the things we focused on here to accelerate the data loading. First of all, it's about easier implementation. With Attunity, you have a pre-built configurable environment with functions that do not require you to do any coding as you would with more traditional ETL technologies that have been around for a long time. Attunity is a more modern environment that takes the whole process of schema definition and maintenance and completely automates the mapping across heterogeneous systems, for example, from an Oracle or SQL Server into a Pivotal environment, automatically generating the target, automatically maintaining that schema, enabling you to add on top of that, if you want, all kind of light transformations or global transformations, all without using any line of code. On top of that, it allows you to very quickly and easily filter the data, so you can only get the data you need into your data warehouse environment, and do it in a way such that if you need 1 table or 1,000 tables, it's pretty much the same amount of effort. There's no additional work required per table. Again, a very different approach than traditional ETL and data integration products, where for each table you have a certain workload that your developers need to do. With this approach, you can easily scale to handle much larger amounts of data without that amount of work required to support it. And out of the box, you get the functions that will extract the data, handle incremental loading or CDC, as well as auditing of the entire process. On top of that, Unity provides an integrated management. We recognize that loading your data is part of your operations, and you need to ensure that it works well, you need to monitor it. So we have integrated management that out of the box gives you a dashboard to visually monitor tasks and performance, to schedule the system for working, whether it's internally or with your external system scheduling, or to get events so you're aware in real time about what happens. You will see more of that in a live demo that we will do shortly that I think will allow you to quickly understand how you can dramatically accelerate the process of loading data while doing it with much fewer resources and required skill sets, facilitating self-service. On top of that, Unity provides a lot of optimizations in terms of the performance of loading data, whether it's large amounts of data, or whether it's continually changing data in your data center or between data centers. So the list you see here on this slide includes 7 different optimizations that are all prepackaged for you within Unity. For example, handling parallel batch loads, leveraging high-speed integration into the data warehouse. In the case of Pivotal, we use the GPF dist, the fastest way to load data, leveraging the MPP capabilities of the data warehouse, and parallelizing the process of loading large amounts of data. At the same time, moving incremental data leverages technologies like TurboStream CDC and log-based CDC, which uses log-based integration to reduce impact on your source system while being specifically designed and optimized for loading a data warehouse and applying data into a data warehouse and MPP environment by leveraging its capabilities to get higher efficiencies and throughput. On top of that, we want to reduce impact on your environment using technologies like zero footprint architecture, which can work without any agents on some of the more common data sources like Oracle and SQL Server, so reducing impact and administration on your environment, and then facilitating and accelerating data transfer, whether it's in the LAN environment, through in-memory streaming, which reduce unnecessary I/O and storage requirements, or by using our TurboStream DX, which is an optimization for moving data across wide area network of the internet. So if your data warehouse happens to be in another data center or in the cloud, we can accelerate and guarantee the delivery of large amounts of data over a network which may have high latency or may be unreliable. So again, at a very high level, facilitating the process, making it easier, and providing a lot of performance. To show that, we're going to show a demo. I have a colleague joining me today, Yossi Shitrit, from our field engineering team. And Yossi will be showing a demo of click-to-load, how you can quickly and in a self-service manner get Oracle data into a Pivotal Greenplum database. We'll see how we can quickly click Oracle as a source, Greenplum as a target, and automatically get an entire solution. So Yossi, over to you.
Thank you, Itamar. Let me start my screen sharing. Okay, so what I'm going to demo today is an application from Oracle to Greenplum for a table that will going to load into Greenplum and then keep in sync with changes that happen on the Oracle source. For this purpose, you can view my Windows VM desktop. I'm going to use Oracle database running on this VM, which has the nav demo schema with list of tables, customer data, for example. We can use that to replicate it to Greenplum. The Greenplum database, the target database that I'm going to use, it's basically the community edition that you can download and set up. It is running on a remote VM on our network. Right now, it doesn't have anything loaded to it. There's nothing here. We're going to create a schema and a tables in this demo. So source and target, and let's open up a Unity Replicate console, which is the application utility that we use to do the replication. The first step, what you can see here are the main screen for the product that shows all sort of tasks. We can create a new one for this demo. Task is kind of a process responsible for replicating from a source to a target. But first, we need to set up the connections using the managed databases. Clicking on the managed databases, we see all the list of connections that have defined. We can define new one, or just for the use, we can use existing one. Let's go from my Oracle source connection. This is a connection that is pointing to my same Windows VM as the source role. So we have Oracle source. Let's do a test, verify the connection is working. And then also Greenplum database connection that is the target connection. We point to the target database. We have the port, username, and password. We're going after the GP demo database in the community edition. And we also provide some information on the local machine for the GPF disk. Unity Replicate will automatically start GPF disk process behind the scene, or can use an existing one, and will transfer the data using CSV files that it's going to create and load to the target. Let's test this connection. It's actually testing connectivity, including GPF disk connectivity. So that's once this is working, we can close it and go back to the main screen to create a new task. Click on a new task, we'll give it a name, maybe a demo to Greenplum. And we're going to use the full load and apply changes for this task. Full load will be responsible for preparing the target tables. In this case, it will create a schema and target tables automatically in Greenplum, including all the data types mapping from Oracle to the Greenplum data types. Then load the data with the tables with the existing data from Oracle to Greenplum. Then the apply changes option is going to keep everything in sync. All the changes that we have on the source will be captured and applied as they happen to the target. So this is kind of an ongoing step. You launch the task and it's going to run and continuously capture and apply changes in near real time. So we can click OK and get to the task screen. So this is the design screen of the task. We have all the sources and targets that created here available for us. We have in the middle a table diagram that we have a source and target. Just need to assign it. So let's assign the Oracle source to it and then Greenplum target. That. And then next step is to select the tables. Click on table selection. We can click on drop down and look at all the available schemas in Oracle. I'm going after the nav demo. You can just type or scroll and click a search to see all the tables. What I'm going to do, we can select tables individually, but I'm going to use the selection patterns to get several tables at once. So we can use include, exclude patterns. So I'm going to include everything, but exclude all the tables that end with one just for this demo. So just do one, I'm going to exclude them. Click OK. Back to the main screen, and I can click on the expand list to see what table is going to be part of the task. And that's it for the basic definition of the task. We can go straight ahead and run it. Click run here. And the task is going to be initializing the tables, and we'll start momentarily with the replication. So here are all the tables getting prepared, collecting the metadata for the task table. We're going to start a process that we're going to run in the background. Actually, going to be two processes. It's going to be the task and also the GPF disk process that will communicate with each other. Itamar mentioned we're going to use what we call turbo CDC, that we use GPF disk for sending net changes to the Greenplum target and applying them in a kind of a merge command to Greenplum. we can see a full load process started. We have tables that are being loaded. The default is to load 5 tables in parallel, but you can change that. So most of the tables here are very small. Again, just for the demo, so full load will be finished very quickly. So tables are being loaded. We see tables are waiting to queue, and the tables are starting to load. We can go and look at the target, by the way, while this loading. And we can do a refresh here. We can see another schema created with the nav demo schema. And let me just a little bit slower this morning. I'm going to expand on the tables. So far we have 5 tables, with the rest going to follow. So we have tables are created. Let's click, for example, on the customer. You'll see the big customer structure. Second, where we can see the data types that we create and the primary key. So here, for example, all the column name and data types. Now, when the folder is going to finish we will proceed to the change processing. So while this is running, I'm going to switch to the change processing to see what's going on. So even though the tables are loading, we actually started capturing changes. So any change that happens during the full load, we're going to capture and apply, and will not miss it. So right now, I haven't done any changes, so there's no activity going on the tables. But you can see here on the screen, got the incoming changes, applied changes, throughput, so nothing is moving here, and the latency, which is where you can see how far behind the target, the source, and the target.
So Yossi, I think we're going to have to wrap up the demo here so we can be respectful of time and give Composite, their share of the presentation here. Appreciate the demo. Itamar, did you have any closing remarks before we move on to the Composite section?
Absolutely. I just wanted to, first of all, thanks Yossi for going quickly through a demo here. We want to give people just a chance to understand how easy we can make the process of moving the data. People who want to find more information are welcome to go to trinity.com/greenplum. You can learn how we can use this kind of product to move hundreds of billions of rows a day and simplify the process of loading the data. Thank you, David, and let's move on to Composite software.
Okay, thanks, Itamar and Yossi. David Bessemer, over to you.
Thanks very much, David, and thanks, Itamar. As you can see from Attunity's presentation, that's a really good way to bring data together to do analytics. What has become clear over the last few years, though, is that there are situations where you either don't want to or can't move data into a singular location for doing your analytics. And this is where data virtualization comes in, is the ability to leave the data where it naturally lives and is managed and still use it for whatever purpose you need to use the data to accomplish something. So what I want to do today in about 15 or 20 minutes is talk about how big data analytics and data management are changing and how data virtualization can assist with navigating some of those changes. We'll talk about the data virtualization platform and a few customer use cases. So when you think about the state of data management, it has evolved significantly over the last 10 years. It used to be that most data was migrated from their sources, whether they were transactional or operational, into a data warehouse. And the business would pretty much run from data that was in the warehouse. Now, this wasn't always sufficient. There were always more sets of data in the operational stores and in the enterprise applications. And occasionally a business intelligence report would need some of that data, and we would use some chewing gum and scotch tape to get that data flowing into the right report. But this is essentially the landscape that existed for a long time, is that the business would get most of the data from the warehouse and occasionally would need to go to more operational or transactional stores to get some more detailed data. And from an analytics standpoint, this was pretty much the universe that the analysts would draw data from and cobble it together on their desktop, maybe using some spreadsheets and building a little sandbox underneath. The problem, of course, is that the world didn't stay this way. Somewhere along the line, the marketing department said that it would set up a analytic database using something like Greenplum and do some churn analysis. And now you've got a whole nexus of data down the hall in the marketing department that has some interesting results in it. On the other side of the building, the sales team probably started using Salesforce.com at some point, and over a period of several years ended up with a bunch of data that was stored in the cloud. And so now you've got data that's not only not in the warehouse, but it's not even behind your own firewall. It's out in the cloud somewhere and has yet another interface to try to get to it. And of course, in the last 5 or 6 years, the rise of alternative NoSQL data sources, Hadoop being the most significant one of those, and the idea that you would capture not just data about transactions, but data about people's clicks through your website, people's GPS locations on their phones. And this activity data is significantly larger and less well organized than the data that we've managed before. So the data management market has changed significantly, and it's still going to change some more. Data as a commodity that you buy and rent from third parties is on the rise. And so as you can see this landscape, it's very, very difficult to go back and put all the data in one place in something like a data warehouse like we used to do. So as we move forward, this is the landscape that we need to deal with. One of the things that data virtualization does is allows you to leave the data in the system where it's naturally managed and naturally lives, and then leverage that data for whatever purpose you need to use it for. And when you think about it, this isn't just about data being in multiple locations. It's about different protocols, different data shapes, different query mechanisms. All of those things create a mess for people who are trying to use data. So we'll talk about exactly how data virtualization works in a few minutes, but the big picture is that data virtualization is an infrastructure that you can put in place to allow you to access data where it lives and use it for analytics or business intelligence or some kind of visibility and dashboarding. Now, this problem is even more acute for analysts than it is for other parts of the business, because analysts are often pulling data together for single use. They're often pulling data together from even more sources than a typical reporting environment. And most of our studies tell us that analysts spend almost half their time finding and pulling data together so that they can actually begin to do whatever analytics they were going to do. Half the time, right? That's a big problem. You should be spending more time doing the analytics and less time doing the data mangling and data marshaling. And what's really challenging about this is it's not a one-time waterfall event like you used to have with your data supply chain moving data into a warehouse. As you start to bring this data together and start to do the analytics, you start to learn what else you need. And so you have to iterate, and you have to go back and find more data and augment. And so this is a very iterative, organic process that builds up over time. Very much how software development has changed from waterfall to a more agile approach to software development. Data integration and data gathering is also having that same change, where you have to move from a supply chain that's one direction, one time, to a more iterative approach where you can go back and change things very easily and bring them together very easily. So data virtualization offers two forms of help for the analyst. One form is a personal version of this that you can run on your desktop and essentially allow you to create your own personal analytic sandboxes. And this is really cool because most of these things you use once and then it leads you to something else and then you build another one. And a lot of this work is one-time work that you may either throw away or archive for a while and go back to it later if you find something else you want to look at. But the point is, it's really not something that the whole enterprise needs to be exposed to. It's your personal work. And so there's a way to create these little analytic sandboxes on your desktop. The second form of this is a more centralized, curated form, where you have some analysis that you've done that leads to some insights that now should be operationalized and shared with the rest of the enterprise. And in doing that, you can actually move this from your desktop and from your personal system to a centralized location that's curated and shared and operationalized with the rest of the enterprise. And we refer to this as more of an analytic data hub. And both of these are options when you have data virtualization in your mix. So let's talk about what data virtualization actually is. It is a piece of software. It's actually a software platform that gets installed in your enterprise. And this platform, you can think of it as a layer above your data sources and below your data consuming application, whether those are analytics or business intelligence or some kind of custom application, doesn't matter. The point is data virtualization ends up as a layer between that allows you to present data as if it's all in one place with a schema that makes sense to the usage that you're using it for without having to expose the consumer to all of these different protocols, data sources, data shapes, and all the transformations that have to go on to rationalize that. Now, how data virtualization actually works is you generally start with the idea that I have some kind of application that needs some data that may look like a particular tabular data set, or maybe it's a hierarchical data set, whatever the case may be, but that data exists in multiple places. And so what you do with data virtualization is you take that reality and you start to use the tools to discover exactly what data is available and what those schemas look like. And this discovery tool is a form of exploration of your data where it profiles the actual data and finds relationships that may exist across multiple data sources. And if you think about this, this is really important because if you don't have all of your data in one place, then there is not a natural schema that defines relationships between the multiple sources. So once you understand the relationships that exist between the different sources of data, you can model your view or your data set or your data service in the data virtualization environment, and you can then even test it and play around with the data. So it's a very interactive environment for playing around with the data and making sure you've gotten it right. And again, this is part of that agile, iterative approach. You can engage, if you're a BI professional, you can engage the BI business user who's going to consume the report. If you're an analyst, you can actually start to use Tableau or QlikView or R to access the data and make sure it's going to serve whatever need you have. And then, of course, you can iterate and modify as required to get the data that you need. Okay? So that's kind of the design time. And then you end up with a set of views or set of data services that you want to operationalize. Sorry, I'm letting my the screen catch up here. And so as you go into production with this, the important part of this is that it performs well. And a big part of the data virtualization platform is a very sophisticated runtime query optimizer that takes a request from the client, optimizes that request just like a database optimizes a request for bringing data from multiple tables. In this case, the optimizer brings data in from multiple sources and then delivers that to the client in the form that was created in this view. This optimization is probably the key point for the data virtualization platform so that you can get up-to-the-minute data with performance that meets your needs and you have not had to move the data into a single location. Now, there are times when doing that kind of data integration on the fly just isn't going to make sense. And so there's another part of data virtualization that is a caching infrastructure that allows you to pre-stage data. And in the caching infrastructure, some of the data is pre-materialized into a cache, and then at runtime, when the application makes a query, that query gets sent to the optimizer, and the optimizer realizes that some of the data is in the cache and can pull that data from the cache instead of from the original source. So by using a cache, as part of your data virtualization environment, you're essentially creating a middle ground between a traditional data integration and replication and a fully live data virtualization that we've been discussing so far, and it gives you a lot of opportunities to do partial integration and partial pre-materialization. So I thought I would just talk specifically about how data virtualization works with Hadoop, and specifically the composite data virtualization works through the Hive environment and the Cloudera Impala environment, and when Hortonworks Stinger environment becomes available, and you've probably heard recently that Facebook has open sourced its Presto environment, all of those are reasonable environments for getting data out of Hadoop. The problem is most of the client tools today need a much richer set of SQL than is available. Putting data virtualization in the mix, you can actually pull data out of Hadoop today and serve traditional SQL-based BI or analytics tools. In addition, you can combine that data that's in Hadoop with traditional data from your other enterprise applications. And this is really cool because even though you've got this huge data lake in Hadoop, you're probably not going to put your finance data in there. And you're probably not going to bring all your Salesforce.com data back over the firewall and put it into Hadoop. So there's a reason that there's a bunch of data in Hadoop, but you don't necessarily want to put all of your data in Hadoop. And so by putting data virtualization in the mix, you can use each system for the right data management and then bring it together to actually perform the analytics from multiple sources. Now, there are times when there is data from some other system that isn't naturally stored in Hadoop that you would want to actually move into Hadoop. And there are ways to do that through Scoop and other things. But data virtualization can also play a role there. Data virtualization can actually sit underneath Hadoop and through Hadoop's input format specification can provide data directly to MapReduce jobs from sources that are around your enterprise. And so you don't actually have to move the data into Hadoop ahead of time to allow this data to be used in your MapReduce jobs. So there's actually two roles here that data virtualization can play in conjunction with Hadoop. So with that background, let's take a look at a couple of customer cases and just talk about how a couple of customers have used data virtualization in conjunction with Hadoop to accomplish a couple of different use cases. So this is a large mutual fund company that you would have heard of if I could use the name. And what they created was an analytic data hub for doing marketing campaign analysis and essentially churn analysis and effectiveness of the campaign. And what was interesting about this is not only did they use Hadoop data as one of their sources, but they used their traditional Oracle and Siebel data, and they also used data from Salesforce.com and a couple of other cloud sources. So that was a pretty cool use case because they brought data together from all these different sources without having to actually move it and created this analytic hub. The second use case I wanted to talk about is another one that uses Hadoop, but it's a little bit different. This is another, this is a global investment bank that you also would have heard of. But what was interesting about this is they needed to do risk analysis and portfolio balancing that required 7 years of data, and a lot of that data had been archived onto tape. So what they did is they used Hadoop to bring that data back to life and essentially create a warm archive. And so now they had all of their live data in their traditional data warehouse and operational stores, and they had what used to be tape data in Hadoop and used data virtualization to make that data look like it was all in one place. That was a pretty fun example because essentially disks are becoming the new tape, and of course memory is becoming the new disk. And this is an example of how that's being put into operation by an investment bank. So one of the interesting things about data virtualization is it's been around for about 10 years. We started the company in 2002, and there's lots of different organizations and lots of different industries that are getting very good use out of this technology. So If you haven't started using data virtualization yet, you're not the first. It's very well tested. There's lots of examples, and there's lots of people that can help you. If you're looking to get more information about data virtualization, there's a lot of sources on our website and around the web that can help you learn more about it. I would point you specifically to this book in the lower left corner of the slide that's on your screen, which is a very deep set of case studies of 10 different large organizations that have been using data virtualization for 4 or 5 years and the successes that they've had in creating not only business intelligence reports, but analytics and dashboards and applications using data virtualization. Okay, back to you, Dave and Tim.
Thanks, Dave. So Tim, I think we're ready to move on to the Q&A session. We've heard 2 different approaches to bringing big data together, so let's take a look at some of the questions.
Yep, go forward.
Okay, so I'm going to take one question off the top here myself. There's some questions that came in about how, more about the business usage of the data. And while that's certainly important, that wasn't really the topic of today's presentation, but I want to point you to the archives where you'll see previous presentations with our partners that deal specifically with the use of the data, whether it's in traditional business intelligence or in more data science-oriented types of analyses. But let's focus on some of the questions for our panelists today. I'm going to start with one for Attunity. Itamar, can you talk about whether or not you can connect to SAP for transaction data? And maybe you can just recap what data sources you can access and the latency typically associated with those connections.
Yeah, absolutely. That's actually that's a very common question we run into. The answer is yes. We have quite a few customers that use our software to access SAP data, OLTP, transactional data, using it either to load the data initially, but more commonly to do it on an incremental, continuous basis. And one of the key challenges, by the way, that they run into is how do you select the right subset of tables, because SAP systems tend to have a lot of tables, tens of thousands of tables, and that's where things like the ability to choose patterns of tables, as Yossi has quickly shown during the demo, to include and exclude patterns for tables can come in very handy. On top of that, we support data, sourcing data, acquiring data from Oracle or Exadata, from SQL Server, from DB2, for iSeries, DB2 for ZOS, Sybase, HP Nonstop SQL, and through ODBC we get to additional data sources, and we keep adding more and more data sources to the platform. And then the last part of your question was about latency. So we first of all see a variety of latency requirements, and we always recommend to customers to understand what is the latency they actually need. People refer many times to real-time or near real-time. We see that for analytics, some people may still move the data once a day, but move only the delta. But of course, we see a lot of folks that are moving data several times a day, sometimes hourly, and then down to a minute or very near real time. So a minute or less than a minute type of latency is something that we see very common, especially for operational data warehousing.
Okay, thanks, Itamar. David, why don't I throw the same question over to you? Can you access SAP data and just a quick recap of data sources and latencies using the composite approach?
Sure. And in fact, it's really important that we access all of your structured and semi-structured data. Excuse me. SAP being one significant set of that. We can access SAP's traditional R3 application through their BAPIs, through their supported mechanisms, and we hide all of that complexity from you and also give you a higher level set of views so that you don't necessarily have to deal with 4-letter German acronyms when using that data. We also access SAP BW so that you can take slices of your multidimensional cubes and integrate those with the rest of your data. So data virtualization really lives in the structured and semi-structured data world. We don't generally deal with unstructured data in a search environment. We deal primarily with structured and semi-structured. So all of your data sources that live in that world can be accessed, including relational databases, web services, Excel files, SAP, and several other applications. And really any data source that you have, we can eventually get to it in some way.
Okay, thanks. And I'll start with another one for you, David. Let's talk about security. The question was specifically about Composite respecting security, or what security models do you use? And then Itamar, I'll come back to you for the same question.
Yeah, security is a really important part of the overlay in data virtualization. And you can think of this in two ways. First of all, when you access these underlying data sources, you want to make sure that the security that exists in those data sources is enforced. And so the data virtualization platform connects to those sources as the current user and passes those credentials or those tokens down to those data sources so that the data you access is accessed as the current user. In addition, because you're doing integrations, there are times when you're going to want to add additional security or different kinds of security that go across multiple data sources. And you can do that in the data virtualization layer. We support a full-fledged authentication and authorization system that you're familiar with select, insert, update, delete privileges and grant privileges. We can integrate with your single sign-on, either token-based or LDAP-based authentication system. So all of the security mechanisms you already use can be integrated with the data virtualization platform and allow you the flexibility to add new data security, including column and row-based security.
Thanks. Itamar, you want to speak to security in the Attunity environment?
Absolutely, and as David mentioned, security is always an important thing for our customers. And with Attunity, we effectively move the data from different types of sources to different types of targets. And with that, we basically integrate and leverage the security infrastructure that our customers have in place. We allow them the flexibility to provision the right access that our software would require to their environment and minimize the access to that and only to that, both on source and the target. And if need to be, limit the access to our product itself, so only the right people may have access because they can access the different systems the customers have. And through that, ensure that only the right people have access to the right information.
Okay, thanks, Itamar. I think we've got time for one more question, and I'm actually going to take that one myself. It has to do with the support model when we, as Pivotal, partner with other organizations such as Composite or Attunity, and how do you, as customers, get support for this combined solution. So our partner engineering organization works with our partners to create a set of products that we support. We publish an enterprise support matrix, and our partners who appear on that enterprise support matrix, we establish a cooperative support model with those organizations so that our support line will take those calls and we'll be able to work with the partner organization to get those issues resolved for you. So there is a coordinated support process when we work with this large partner community. So I think, Tim, we probably ought to wrap it up there, and I'll turn it back over to you.
Okay, sounds good. Thank you, David, for moderating and fielding those questions. We had a lot of questions come in, so thank you to our audience for participating. For those of you that did not get an answer today, I want to assure you that we will be sending the questions to everybody on today's panel, and you will be receiving a follow-up following today's webinar. I have just a few quick announcements to make. Please mark your calendars for December 10th and our next Data Science Central webinar, Turning Obstacles into Advantages, Solutions for Visual Data Mining and Predictive Analytics, which is sponsored by Actuate. Also, as I mentioned earlier today, we are taping this event. It will be available later on this afternoon and can be found on datasciencecentral.com, and it will be also on our partner's website through Pivotal. This brings today's webinar to a close. I'd like to thank our audience again for their attendance and thoughtful questions. And thank you to Pivotal for sponsoring today's event, and Dave Menninger for his very good job at stewarding us through today's webinar, as well as our panelists, both Itamar and David Bessemer. We appreciate your perspective and time. My name is Tim Madison. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on December 10th. Good day.